Hey, DevJuniors! Are you getting tired of all the talk about super complex neural networks and deep learning models? Sometimes, the simplest solutions are the most elegant and surprisingly powerful. Today, we're diving into an algorithm that proves just that. K-nearest neighbors, or KNN. It's so straightforward, you'll wonder why you haven't used it more. This is the ultimate lazy learner of the machine learning world. And by the end of this video, you'll understand exactly why it's a must-know. So, what exactly is K? First off, it's a non-parametric, instance-based algorithm. That sounds complicated, but it's not! Non-parametric means it doesn't make any assumptions about the underlying data distribution and This is the fun part! KNN, does UNT learn a descriptive model from the training data in the way other algorithms do? Instead, it just memorizes the entire training data. That's why we call it a lazy learner. It postpones all the real work until a new, unseen data point comes along that needs to be classified. Its primary job is classification, deciding which group a new piece of data belongs to, but it can also be adapted for regression, which is predicting a continuous value. Let's get to the core mechanism. Imagine you have a chart with a bunch of data points. Some are blue dots, and some are red dots. They're all nicely categorized. Now, a new, mysterious data point appears on the chart. Let's call it our little gray, ? How do we decide if it should be blue or red? This is where KNN springs into action. It calculates the distance from our new gray point to every single other point in the training set. The most common way to measure this is using Euclidean distance, which is just the straight line distance between 2 points that you probably learned in geometry class. It sounds intensive, and it is, but the concept is beautifully simple. Find out how close our new point is to everyone else. This is where the K in K nearest neighbors becomes the star of the show. K is a number that we, the developers, have to choose. It represents how many neighbors we're going to consult to make our decision. Let us say we pick K equals 5. The algorithm will find the 5 closest data points to our new gray ? Once it identifies those 5 neighbors, it holds a little election. It looks at the colors of those 5 neighbors. Let's say 3 of them are blue and 2 are red. The majority wins. In this case, blue has the majority vote, so our new gray point is officially classified as blue. That's it. It's classification by committee, where only the closest neighbors get a say. Now, choosing the right value for K is absolutely critical. It's a classic balancing act known as the bias variance trade-off. If you pick a very small K, like K equals 1, your model becomes very sensitive to noise. It just looks at the single closest neighbor. If that one neighbor happens to be an outlier or a mislabeled point, your prediction will be wrong. This leads to what we call high variance, creating a very jagged and unstable decision boundary. On the other hand, if you choose a very large K, you might overgeneralize by considering too many neighbors. The model can smooth out the decision boundaries so much that it misses the local, subtle patterns in the data. This leads to high bias, where the model is too simple to capture the underlying structure. Finding that sweet spot for K is key to a good KNN model. Of course, KNN's beautiful simplicity is also its biggest weakness. Remember how it has to calculate the distance from the new point to every single point in the training data? That's not a big deal for small data sets. But imagine you have millions of data points. The computation gets incredibly slow and memory intensive. This problem gets even worse as you add more features or dimensions to your data. This is famously known as the curse of dimensionality. So, with these limitations, where do we actually see KNN being used in the real world? You'd be surprised how often it pops up. Another big area is in finance. For things like credit scoring, a bank can classify a new loan applicant as high risk or low risk by comparing their financial profile to the profiles of previous customers. And there you have it! Nearest Neighbors proves that you don't always need massive complexity to get powerful, insightful results. It's a foundational algorithm that serves as a fantastic entry point into supervised learning and is an essential tool to have in your data science toolbox. So, what's your favorite distance metric to use with KN? Is it Euclidean, Manhattan, or something else? Let me know down in the comments. If you found this breakdown helpful, be sure to hit that like button and subscribe for more essential algorithm explanations. Thanks for watching, and I'll see you in the next one.